Today I would like to present and talk about 7 things which you should care about before release your code in production. To be honest, it's not the 7 things, it's a bit more, but it's grouped into 7 things. Probably it's around 15 or something like that, but there's 7 groups what I would like to talk about. So this is the agenda. I would like to talk about the versioning things in the Go, profiling, health checks, logs, performance, and monitoring and alarming and release process. Okay, so that's the agenda, and okay, we can start. To be honest, it's not a soft presentation, it's rather more technical. So there will be lots of code examples of things. Okay, so firstly, before you release the code, you have to think about the versioning things. Usually at the beginning of the project, you are not thinking about the versioning API, versioning DB, or so on. And during the development process, it's rather obvious that people just develop things and don't care about the changes in the API. But to be honest, it should be done before the first release, because in that way then you will have lots of better and easier to maintain your project if you think about that before release and before the first release. Okay, so I would like to talk about the version builds, so versioning builds of your application. So that's pretty easy. Usually you can do that in a way that you have a tag in the Git, you build the application and put it somewhere, and that's rather obvious. But in Go there is a way to embed or to put the information about the build to the binary file. So we can for example pass some information about the version of the last commit of the build time, or some envas or so on. So how we can do that? So this is a bash. So those first 4 things are just information from the Git. So in the first one, we'll just get the describe of our repo. If we have a tag, then this version would be named by the Git tag. Then we can get some information about the commit. For example, last commit user, hash, and time. And then here is the whole magic. Here is how we can pass the information to the build file during the build process. So then we can call the minus all the flags, and with the -x flag we can embed all the information. Here is a prefix main. It means that the build will be looking for the app version variable in the main package. So here is how we can pass the information, and then we are building Go file. And here is the how it's done. So we've got global variables, and all of them are set to unknown. And then we can, by this Go build minus all the flags, we can pass this information to the build itself. And then we can print the information. So we can have a look how it will be in the real example. So we've got the versioning things, and then we've got builds, and here is a build. This is the bash script. I will cut it just to show you that it's not a magic. This is exactly the same what I've put on the slides. So we can run it, and we can see that all the informations which are from the outside of the build are inside the build file. It's really nice and really great if you, for example, would like to show the build info in the health check or in the logs. Sometimes it's a really nice example to put the current version which is deployed in the logs as one of the parameters. Okay, so we can go to version artifacts. It's pretty common that when we build something, then we should put it somewhere and store all the version. Then if the client comes to us and asks about the some particular version, then we can download it, run it, and check, test, or anything. This is maybe not connected with the Go itself, but it's a more general thing. But of course, we've got Nexus for Java. We can use the FTP and put everything there in some directories. We can use the GitHub, Bitbucket, Codeplex. All of them have nice API to put it by ourselves. We can also, if we have a Docker images, then we can use the Docker Hub or private registry. So there is lots of alternatives to do that. Here is a simple example. If you're using GitHub and if we have a great, open source project, then we can of course put our binary and we can even automate it by this GitHub release application, which is of course built in Go, as you can expect, and you can just put the user repo tag and path to the file, and this file will be uploaded. And it's pretty straightforward to do that and automate it, even if in our CI or something. Okay, then it's the API. It's a bit more complex things. I don't want to cover all the ways and all the scenarios how we can version API, but you can imagine that if you've got mobile clients and mobile applications, and we cannot force the users to upgrade the version to the newest one, so we have to support the old one and the new one in the same time. So how we can do that? Of course, during the development process, there's not the problem, but after the release, if we have backends in the Go and for example iOS application or Android, and they're using our API, we have to provide this backward compatibility, because we cannot force the users to do the newest release. And so there are two main ways how we can do that. First one is by this extra prefix or extra number in our API and in the URL, and another one is by the header. And there is maybe not the war, but there is lots of discussions and pros and cons of both solutions. I don't want to tell you which one is better. In some scenarios, the first one is better. In some, the second one. Privately, I used the second one approach in two projects, and we were pretty happy with that. So I cannot say that I recommend that, but we use that and it works since even now. So okay, so now how we can do that in Go? The first one. So if you would like to have an extra prefix, we can have we can use these routers. For example, this is MUX. MUX is of course the Gorilla MUX. I'm sorry. If we're using the Gorilla MUX, or for example the HTTP router has exactly the same, Echo HTTP server has the same or similar APIs to do that. So we can use subrouters. If we're using subrouters, we can have it's like a tree. So we are starting from the API, and then we've got we can group our API into the two subrouters, and then we can handle FANG, which is a test file1 handler, and this is connected with this subrouter first and the subrouter second, and then we can by this the prefix file1 and file2, we can have both APIs working in the same time. We can of course run it. We can see that this handlers, this is not the magic, we are just printing the API file1 and API file2, so we can use curl, or we can copy that in the browser. So we've got the API file1. If we change it to file2, we've got the file2. So it's pretty straightforward. So this is how we can do that in the MUX. And another approach, the second one, is by this header. It's a bit more complex, because we have to create another and the extra middleware here, and we have to wrap our handler by this version middleware, and in this middleware we have to call extra endpoint handler which accepts this response writer request and the new parameter int, which is in fact the version which is injected automatically by this method accepted version. So here's how we can do that. Just add the middleware, and then here is a method which gets the particular version from the header. How it's done? It's pretty easy. We've got, for example, the map of the supported versions. For example, vendor, test app, file 1, and those are the headers which points to the particular API number 1 and number 2. And if the request comes to our server, then we are trying to find out the accept header, and we are trying to split it by the plus sign, and then we are looking for this particular string in our map. If there is a no this version, then we are using the default one, just the fallback, and if it returns something bigger than the default one, like 2 or something, then we of course return it. So it should be pretty straightforward. And then the problem with that is that in the previous approach we've got the easy things that we've got different handlers for different versions of the API. Here we've got exactly the same handler, and here is the information which API it is. So then we have to manually check whether it's API 2 or 1, and this is a bit sometimes more problematic, because then we have to put more ifs in our code, and sometimes we have to pass this information about the version downside to the service layer, to the database layer, and make lots of ifs. But for example, the problem with this previous one, with the subrouters, is that we have to copy lots of code. So then we have, for example, 2 the same handlers, and they are, for example, doing almost the same things, and then we have to copy almost all the code. And in fact, it depends on the requirements, on the architecture, and many things which approach use and choose. But I guess we can also check whether it works or not. We can run it. Okay, and right now it's a bit more complicated to test this second scenario, where we've got extra information in the header, because we have to use the curl, because in the browser it's not so easy. So we can put this extra header accept, and then we've got application vendor test app file 2, and this is a version of our API. Of course, it returns file 2, and just to show that, for example, if we put it some sheet or something which is not proper, then we've got a fallback to the version 1. If there is no header at all, of course, it's also the version 1. Okay, let's get back to the slides. So this is about the versioning API. Do you have any questions or something? Or if you have any questions, then you can just raise your hand or have a question at any time. Okay, so then we've got versioning static files. This is pretty common in all web applications, and this is pretty straightforward how to do that, I guess. So we've got 3 options. We can serve all the statics with some prefix in path, which is a revision. Of course, the question is why we are doing that. Like Dan says, that the browsers usually, or sometimes, or it depends on of course, the handlers and all those settings in the HTTP, they are caching static files, images, and so on. So sometimes, if we release new application, we would like to force the browser to get the newest JavaScript, CSS, and images, or so on. So that's why we are using this versioning also here. So three approaches: one with prefix, another one with extra query arg, and another one is just to put this also in the file itself, in the file name. So those two, the last two, are I guess not connected with the Go at all, but I would like to show how to do the first approach, where we can serve the statics with some extra prefix. This is pretty easy, I guess. Anyone who serves some files from Go should know this approach, where we have this HTTP strike prefix, which this is a bit more complicated because in this example I would like to show that we can serve the files with this extra information about the version, but also I would like to serve the files without this version. So this is like the fallback when someone, for example, we've got old clients which they don't have this extra information in the URL, and in both way we are getting the same file, so we can strip this prefix S, and then we can serve all the files without any information about the version. And then we've got in this line we are serving this static roots, means that this static root with the version and the path. So we can of course okay, there's no play here, so I'm going to go and run it. Okay, we can test it. So here are the examples with the extra version in the path and without the extra version. Both of them should serve the pretty simple index HTML file with the hello information. So this is the first one, that's the second. Both of them are serving the same directory from my computer. So this is how we can do that in a Go, and how we can version static files. Then we've got the versioning of the DB. This is also something which it's important before the release, because then we've got of course some changes, and usually we don't carry the development, then we've got some problems. So it's really good to start using these tools for versioning DB before the release. So there's lots of options here. It's not also that the topic is not connected with the Go, but I would like to mention that it's also important, and if you would like to in some near future release some code, then you have to think about that as well. The important thing is it should be automatic, so I think that we should have at least some scripts which do that for us, or some Ansible or some other ways how we can automate that. We can use some extra Docker with all the schema itself, which runs it on our database. Important things that we can think about the reversible, so how we can roll back the database. All the tools like Flyway, Liquidbase have this way, and they can roll back the version. So if something went wrong, then we can just revert the changes. For example, we would like to create a table, and he noticed that this table already exists, then we can just, for example, in that way, in this complete scenario, then we are just doing nothing, but sometimes we have to, for example, change the name of the key, or there are lots of more complicated examples. So we can, it's not connected with the Go, but there's lots of tools written in the Go to support that, and at least I found those 5, and they are pretty nice. For example, this the first one, Migrate, supports at least few databases. So we've got Postgres, Cassandra, SQLite, MySQL, Mongo, and so on and so forth. So, and it has almost 900 stars, so it means something. So yeah, so probably Ben says she has something around that. We can have not too much, not too many. Okay, not too many. 100 and 500. Okay, so we've got the winner. So you should choose this one. Okay, so this should be straightforward. Please do that before the release your code. It will help a lot to you, and it's really important. Then we've got the dependencies. This is something which is, I guess, one of the most important things, because probably know that, I'm sure that you know that dependencies in Go are usually not stored anywhere by default, so they are always get from the GitHub repository or someone, and this code can change anytime. So if you have some CI, you should store the dependencies at the time or before the release, because then you're pretty sure that your code works. Otherwise, you cannot provide, you cannot be sure that this code somewhere in the GitHub repository of someone's does not change. For example, I guess this nice example of Sirupsen Lobros. I don't know if you heard, but this guy changed this first name in his repo, in his GitHub, from the uppercase to lowercase, and he broke lots of code repositories. So be aware that it's really important to version dependencies. There's also tons of tools to do that. I guess the most popular is GoDep, which is one of the oldest one, and there is also Glide. This is pretty new, I guess, but it's really popular right now and at the moment. How we can do that? It's pretty easy. Okay, there's another. Okay, so it's more even another 6 months. Okay, so it's example in Glide. In GoDep, you have to just type GoDep save. I guess minus R, and then all the dependencies which are in this directory are downloaded and put in the vendor directory. Since the Go 1.5, I guess, it's by default set, and if the dependencies are downloaded, the Go knows that that the Go tries to look for the dependencies in this vendor directory. So previously there was some hacks to do that, and after the Go 1.5, it's set by default that the dependencies are in the vendor directory. So if you have, for example, using some GitHub repo and GitHub library of someone's, and we've got a vendor. So firstly, it tried to fetch the dependencies from this directory in your local repository. So here's an example of the Glide, so we can check how it works. We can go to, for example, this repository, and we can try to, Glide create, okay, Glide create. So he's scanning the whole repository, and he's trying to find what dependencies I'm using, and then he found some reference to, for example, I have 8 different dependencies, and then if we type yes, then he will try to put everything. He creates this extra Glide YAM file where all the dependencies are stored, so there is information in which version of this dependency he downloaded to the vendor, and what is exactly the last commit hash, what's the time of the dependency, of the download of this dependency, and so on. So this is how it's done, and I guess this Glide is pretty nice. I haven't used it, but I guess if I would start a new project in Go, probably I would choose Glide because it's pretty nice. We can of course then if we would like to get some new dependency, we can type glide get, and then he will just automatically put this dependency in the vendor directory and insert some information in this glide YAM file. Then we can go build. We can of course the build application with with just Go and just to create a binary, and then we can glide up to just update all the versions to the newest one. There's also lots of different things which you could do with Glide. As I said, there's also the GoDep, which is pretty popular, and 8 different ones. So basically, if you have some questions or if you have for example, you're looking for some dependency and you would like to, for example, check what are the options to version the database or to find a proper tool for managing dependencies, I usually use AwesomeGo, which is pretty nice repository, which contains the list of some nice stuff regarding some particular subject, like databases, like networking, like logging. For example, here's the list of the loggers in Go. And if you create some super nice open source repository, then you could also create a pull request and put it here. There's also some section for the conference in Go, so it's pretty nice if you are looking for something and you don't know what this tool could look like, or what's the name of this tool, or you would like to check whether such tool exists or not regarding some particular area, then you can check on this list, which is pretty nice, and it has 70,000 stars. It's almost same number as in Go, because Go has, I guess, 19,000 or something, so high number than the Go, which is same. Okay, so that was the versioning things. The first, big topic, big subject, what I would like to talk. The another one is profiling. It's pretty easy. I made a talk about the profiling and how to improve the speed of the Go. I guess it was like half a year ago on the meetup. So I don't want to, talk about how to profile the Go application, but I would like to tell you one great clue what you should do before you release your Go code on the production, because by default the profiling is turned off in a Go, so it's really nice and it's good to turn it on before you release the code, because then in any time when you, for example, have a code which is somehow running slowly, then you can go to your production server and create the profile, and you can just create the pre-profile and analyze the speed, the heap of your code, the whole information about how and why your code behaves so bad or anything. And by default it's pretty easy. So if you're using the standard HTTP router without some extra things from the Gorilla or from the Echo or anything, then it's pretty easy, because then you have to just import blind this net HTTP pprof package, and then by default under some path exactly debug pprof profile, your code will be you could analyze in whatever moment your code and create a profile. So we can have a look at that, we can run it, and we can, for example, just show you. Okay, so now we would like to check why our program is so slow. So we are using this Go to pprof. I don't want to talk about the details, but in fact it just try to analyze your program for 10 seconds and find out why it's what exactly the program is doing at the moment for this 10 seconds. So we can run it. Right now we've got the 10 seconds of this analysis, and then we can just hit our browser many times just to analyze what is happening. Okay, so the profile is saved. We can type top, which shows the person, like this. It shows by default the top 10 invocations of your Go code where it spends the most time. So right now you can see that 91% of the invocations of the time of the computing, because right now we are, I don't know if I mentioned, but the profile, this is the CPU profiling. So we are analyzing the CPU. So 91% is here in the math power. You can have a look that we were we were calculating some big power, like 23 of 78, probably it's a huge number. So we can also analyze this profile in the web. Then we've got some nice insight what exactly is done in our application. So we've got all the stack from the defaults HTTP server. Then we've got our handler. Then we've got math.pal, and then we have all the things where the CPU is what the CPU is doing. So, but no, it's not about the profiling. It's about the fact that by default it's turned off. So you have to turn it on, and in that way you can analyze your code in whatever you want, even if it. And of course the question is if it slows somehow your application, turning it on. But the answer is not, because by default it's doing nothing. So it slows your code when you start profiling the application. Then it's the moment when, in fact, your code will be slower. But it's just 10 seconds, and then you will know what is happening on your server. So this was the pretty easy way when we are using the standard HTTP router. It's a bit more complex if you would like to use it in for example in the MOOCs, like in the Gorilla router, because then we have to attach profile by ourselves. So we have to tell to this router that under those particular paths are those particular handlers. So by default it's attached to the basic and to the standard router, but if you're using something some external router, HTTP router, then you have to turn it on by hand. So yeah. So then I would like to talk about the health checks. it's pretty.
I have a
yeah.
question slash info that you can also execute this profiler as a separate server in the application, so that you can have the application itself using the Gorilla Max or MOOCs.
Yeah.
And then in another Go routine you can start another server on a different port just by using this default this blank import, and
yeah.
you can profile it and have it on a separate port.
Yeah, that's true, and this is pretty cool because that that provides some security problems. If you have exposed your API to the world, then all those endpoints are available for someone from outside. So yeah, that should be here. I'll fix that. Thanks. Okay, so health checks. Health checks. Okay, the question is, do I need health checks? Okay, so in that architecture, if you've got 3 or more web servers and we've got a load balancers, that's pretty obvious that it's pretty cool and pretty nice to have a health check, because then the load balancer knows which of this server is up and running. By default it uses just a /, so it tries to find if anything is under this health check, but it's cool to create extra endpoint for this health checks, which comes from the load balancer. So in that architecture it's pretty obvious. But how about that? In that way, where if we have a Go server and all the users are using directly our server from the outside, the question is if we really need the health checks. So the question is that, like, the answer to this question is that you don't have to, but it tells you lots of things about your project. And I guess it's really cool to use something which is called Health Z. This is like something which was maybe not invented, but populated by Kelsey Hightower. This is the guy who's working in Kubernetes in Google, who's pretty nice in Go, and he has great talks, and he always does great shows on his talks. So it's really worth to see his talk, and he claims that it's really nice to have more extended health checks. So health checks which tells you that your server is up and running and returns okay. In the response tells you in fact nothing, because for example you can think whether your database is up and running or not. And sometimes you would like to have just check to pretty easy and pretty quick and fast to check what's if your server is up and running, for example at the database layer, or all your some services which are not under your jurisdictions, which are somewhere outside of your infrastructure, are up and running. So the idea is just to put as many things as possible in the health check. And the idea is to put, for example, what is the current app version which is running on the server, what is the last commit, what is build time, when, for example, so this is an example which is taken from the versioning of the builds. So this is pretty easy, but here are, for example, the started app. So it also tells you since what time your server is up and running. So if, for example, you got a system D which rerun your server, sometimes you can have some problems, for example, with the memory, and your server can die, and you will even not notice that something is wrong with your server. So this is also pretty easy to just have an insight that your server has been restarted, because as you will see, we can also print such information. So here is how we can do that. It's an extra endpoint health and health zip. This is the handler. Here is the basic information about the build. So, for example, what is the app version, what is the build time, what is basic information about the last commit of the applications which is up and running. So here is also another information like the host name, when was started, what's the uptime. This is just to have a better insight and just to format this information and just to show that what's the build and what is the database status, for example. But you can also check all the external services or servers which are which you, for example, depends on. So this is pretty nice and pretty cool. So we can this is for example how to check whether the database SQL database is up and running. So we're just opening the connection, and then if something is wrong, then we are returning the status in the map that something is wrong, and we are doing ping, and if something is wrong also we are log that, and if everything is up and running, we're just putting here okay. So so we can have a look. Recognizing that, and close it, so we can just run it. Also, I've got the bash wrapper because those flags with extra last commit and information from the game. So this is how the health Z health checks looks like. So we've got nice information, for example, about last commit. So we don't have to think about if, for example, this particular commit was involved in your release or not. Then you can just check git log and then check whether your application has this change or not. Build time, host name, uptime. Of course, if I reload the page, then our uptime is 44 seconds. When the application was started, when was built, and what is the current status of the database. So this is something what I would like to somehow promote, because it's I guess, and in my opinion, it's pretty nice to implement.
If you are running your Go application in Docker, then you can just ping this endpoint from inside the Docker. So this is the new API in 1.12 version. So we can just write a special health check in your container, and then if you type docker ps, you will see the health status of your container.
Okay. Yeah, because like people from the Go, I guess, Also, this health zip is used in Kubernetes as well. So I guess it's a common approach to a bit improve the health checks and to put more information there because it's a worth, I guess. Then, for example, like I can show you that I've got also some application which is right now at the moment up and running. And for example, I've got even IPs over my database. Also, I've got some information about the schema. What is the database schema deployed in those Cassandra database here and here? What is the host name? Its uptime is 24, I guess 246 hours, around 10 days. And
how about the security of this path?
yeah, it's not
secure?
secure. It's not secure. So you can type it. You can even copy this, URL and put it, and you will find that. So this is all public. So yeah, the IPs are a bit insecure, I guess. But to be honest, I have configured the security group within this cluster, so only 2 IPs in somewhere else are available to connect to that. So I'm pretty sure that it's secure. But yeah, but this IP is not the best idea, and I talked with Pavel and he said that's also not the best idea to put this public IP here. But okay. Okay, so it was about the health checks, and now about the logs. So I don't want to talk about what to log or what to not to log because this is a topic for the big presentation. So I don't want to talk about that. So I would like to tell you about something different, something which is maybe not so popular or not so well known. So the first thing in Go which you should use is just to use this structured logger. I think it's really important to use some JSON stuff or anything which is structured. So the best thing in this structured logger is that you can then put it somewhere in the log aggregator like ELK, like the Elasticsearch or New Relic or any other thing, and then you can just index all the fields and get some extra information from that. And this is something which you should do before the release. Then I would like to talk about the context, and I would like to also somehow promote the log aggregators, and I would like to show you that it's pretty easy to run it even without some extra infrastructure, and you don't have to run the Elasticsearch in a cluster of 10 nodes. Firstly, use structured logger. It's really easy. If this is example with loggers, then you can just use formatter and the JSON, and then the way how you log information is a bit different. So you can't enter all the information with this percentage S way and the F and font, printf and all that stuff. You have to forget about that. You have to use these extra fields. So you have to log information with the fields. So this is a simple information that here is inside the log, and here are the fields which are attached to this log. And this is how it's done, and this is something which is changed a lot in your application. So it's better to think about that at the beginning of the your project, because changing it at some point where, for example, you are developing the application for a few months, it's a pain in the ass. So probably you won't do that. So please, when you will start some new application, you go use some structured logger. So this is the output. So we've got everything in the new field. So we've got the message, we've got the time, we've got this level, which are the most important things, and also this extra field, which is, for example, lang. Okay, so but this is just to use structured. But why it's cool, and where is the power of the structured loggers? So this is, for example, simple example of square the numbers. So imagine that we've got a server which has one endpoint square, and you would like to square the number. So here you are just getting the argument from the URL path, and then you just parse the number, calculate the power of this number, and print the result. Pretty easy. You can run that. We can, for example, see that if our argument is 4, then the response is 40, which you can expect. And of course, if we see in our logs, we've got information that we've got argument 4, and the square of the 4 is 60. And this is a pretty common pattern where we are just, have some context. We've logged the information that we got some arguments in our invocation of our method, and then we just calculate, and we were just printing the square, the return value which we are returning from this method. So this is pretty obvious, but what will happen if we just copy that? If you don't know what's Hey, it's a tool to monitor the performance. So right now we are run the same request with 100 parallel connections, and we will do 1,000 requests. Okay, we can run that. We've got extra histogram of our requests. I highly recommend this tool for some simple and fast performance tests. But I would like to show you the logs and how they look like. So here is an example where our current approach to logs fails. Here we've got the argument 7, and here we've got argument 7, and we have absolutely no idea what is the connection between those four, between the argument what we've got and the response what we've calculated. So this is where the context of the logs is really important. Sometimes you get some information, you get some arguments, then you log that, but if your server has 100 parallel connections, then probably your logs tells you nothing if you don't have a context where you can match all the requests and all the single lines in the log file. So how we can solve that? We can use something which is context, and this is exactly the same example, but at the beginning, when we have a handler, we are create the new context. I will just describe it in the next slides. But you can imagine that we are creating the context. We put it here, new number, new unique number, and then this is the way how we can track the invocations, down to our application. So then we are just passing this context to all the invocation at all layers in our application, and this is how we can track and log things in a really nice way. So we've got the square value, and we are not passing only the argument, but we have to pass this context, and this is a pain in the ass because we have to pass this context, which is a golang context, but this default golang context down to every single invocation of our method, and this is something which is not so cool. But the pros of this is pretty nice. So this is how the square value looks like. At the beginning, we are creating the new logger based on the context, and then we are logging the information. So this is something which a bit complicates our logs, but it's worth. And I will show you why. And in the example, just a second, I will also show you how we are creating the new context. So this is a Zap. Zap is a logger created by the Uber. But the fact is that you can do exactly the same with the logros or with any other structured logger in the Go. So here is in the init we are creating the default logger, so the one which will be the base, and it's the root of all the loggers. So all the loggers within our application are in fact came from this logger. So we've got some information about the PID and about the exe. So it means that we know what is the PID of the process which is running and what is the file which was executed in Go. So we've got a method with request ID, which in fact, based on the context and this request ID, create the context with this extra value injected. And here is how we are creating the logger. So at the beginning we are just copy, not the copy, but in fact to just assign the logger. Then we are checking if the context exists. If not, so if someone passed the nil here, then we are returning the default one, this one. If not, we are put the request ID with this logger. So why is cool and why is worth to spend lots of times and to improve our loggers. Here's the example. Okay, we have to go from here, and we get. Okay, the response is exactly the same, but here is the information which is really nice. We've got the request ID, and this is how we can match all the logs which are created with this particular request, and then we can have a history of all the logs with our system. And the truth is that another win of this solution is that if we'll come here for a second, that we are passing this context, which is the default context. So the win is that, for example, if we would like to create the cancellation, for example, of our request, or we can use this context to many things which are promoted by Google right now. So I don't know if it would be really cool to create the new talk about this context. So we can, for example, use this context to execute a query on our database, to track the performance of our database, to track for example, we can integrate with gRPC framework. We can implement, for example, some context and passing some information between the external services. For example, we can base the whole microservices infrastructure based on the same context. So we can even pass this request ID in this context to another server which is somewhere else in our infrastructure and log exactly the same ID with that. So this is really cool, and we can even implement the distributed logging, and all the logs will have the same request ID which was created at this handler where we are creating that. So this is pretty cool, and this is I guess the problem is that you have to pass this context everywhere. But the win is that then you will have extra logs, and you will have great insight and all the great things which comes with this logger. Okay, so that was about the context and why you should care about the context. This is a small thing, but I would like to also somehow promote the idea of logging the errors from the front-end applications or from the JavaScript, because usually we don't care about that, but we can use a sentry to log that, or we can implement the new endpoint just to log every single error on the web application, because sometimes we even don't know if our JavaScript or the front-end app is working or not, and it's really nice to correlate the logs from the front end and from the back end, and this is how we can do that. We can expose extra API for that loads, or this is how we can track the information if our front end app is up and running or not. I would also recommend you to use log aggregators. Of course, if you have one single node, maybe it's not worth, but then you can use a grep and you can find everything there. But nice thing is that it improves security. So if you, for example, someone will hack your computer and change everything, then the fact is that even if he clean up after he's attacked, but the logs will goes to these log aggregators. I had once some security audit from F-Secure, and they say that this is a medium level of the problem with the security, so pretty high. So they recommend to use the log aggregators. Of course, the options: Elasticsearch, Splunk, Graylog, Logly, and many more. This is, in fact, people think that it's pretty complicated, and then you have to integrate tons of things, but in fact not. There is a Docker Compose for that, which is pretty nice. And this runs if you have a Docker on your computer in just a second, like a few, and then you have up and running the Kibana, which just shows your logs. And how we can integrate with in Go is just to, this is example with loggers, but this is there's many different loggers which are also use something similar. So if we have a loggers, we are just creating the new log, and we have to just do that once in the whole application, and we just register a new hook. And the new hook is something which is called every single time your logger will log something. So if your logger logs one line or one log, then this hook will dependency where this guy just sends every single file to the logstash. And here is how we can do that. So this is just creating the hook, add hook, and that's it. And in wherever place within your whole application you will log something, then this will goes to the Elasticsearch. So we can run that. We've got some simple log that's hello Wrocław. We can run Kibana. You can see that the one log came, and we've got, for example, all nice information here: timestamp, version, level. We can query that with all the wildcards and nice things. We can, for example, close that. We can, I don't know. Okay. Yeah. we can run that, and we can see that probably if we'll type that in Kibana, we'll find that. So this is really easy, and
with little work you could parse this field in the logstash to get extracted all the fields from the.
Yeah, I wouldn't say that this is a small work, but yeah,
Okay.
we can do that. So I would like to highly recommend you log aggregators. It's really easy to. Right now in the GitHub you can find tons or different dependencies which will do that for you, and which will just grab all your logs and put in Elasticsearch, for example. Okay, the performance. This is something which usually, if you have a project, there is not time for the performance test or for the stress test or for any that kind of test. But I will highly recommend you to please do that at least once. And before that, of course, you should turn on the monitoring and the alarms and see how your system behaves. But do that once, and just to see and just to find out if your system just survives such great number of requests or anything. This is really easy. Those tools, those two tools are written in Go, which are really cool, which have a really simple API, and I use this Hey tool, where you can just test your API within a few seconds. Just type the URL, number of requests which you can do, and the number of parallel connections. So it's really easy, and please just do that once, just to check if your application will survive or not, and how it behaves. And then you have a really nice histogram where you can see how many requests were under this particular time. So this is also nice. You've got some statistics like the average, the status code. So if your server denies or returns on 500, then you will see also here. So it's really easy. It's written in Go, and it takes a few seconds to just test your application. So yeah. Then what we've got, monitoring and alarming. This is a huge topic. This is also a topic which probably should be at a different talk and not as a part of mine. But just to know that the first one, the monitoring should never require a human to interpret any part of the alerting domain. So if you have a monitoring, if you monitor your application, if you monitor your request, the latencies, the number of 500s, the number of 200s, or the average time of response, so, but which is a bad idea, but the idea is better is just to track the histogram of your request. But please do that and configure the alarms just to automatically check that. And the output of such alarms, I guess there should be three things. This is pretty complicated, of course, but to create the system which arms you in three ways, where there are the alerts, the tickets, and the logging. So if something happened and no action is needed, then you can log something in some extra console and some extra logs for monitoring. There's also idea of creating the tickets when something is really bad, but not so bad to access the server immediately. And there are the alerts where the action should be taken immediately. So this is all those things are taken from the SRE Google book, which was written by someone from Google about the SRE, the site reliability engineers from the Google wrote this book, and it's really cool. This is like just to I guess define the best and the most important things. And this is also important. If you SSH, if you have to SSH to your server, it means that something is wrong. So probably you have to automate something, and you have to somehow find out the way to automate your infrastructure, because the biggest problem with the monitoring, and like not the monitoring, but with infrastructure and ops is the faults which are created by the people. So it's pretty obvious. I would also want to show you some simple example how to also prove that this monitoring is really easy to go. And even if you have one server, then there are even the solutions which are which allows you to create and to monitor your server like a single server for free. So this is a integration with the Librato. So I will describe what's going on. In the first one, we are just register all the information regarding the garbage collector, and we are telling that each minute the information should be sent to the Librato. Same for the memory. Then we've got a client which is a sender which has my login, which is logging in Librato. Librato, I will just in a few seconds show you the tool for monitoring, which is external tool and which is for free if you have just one or two machines to monitor. There is a token which is for security reasons, and a host name, of course. And then we can register even some custom errors, and we can have one single handler, HTTP handler, which will increase this error, and we will run this server on the port 7001, and I will show you that it's I've wrapped that with the bash because I put the token there. Okay, so you can see that this is a Librato. It's let's see, and let's make some requests here, and we can wait a minute, because each minute the statistics are sent to the Librato, and and in a couple of seconds we'll get the information, and we'll find out that monitoring and alarming might be easy, and it's really easy in Go. This is these things you have to do only once at the beginning of your program, somewhere in the main probably function, and then you will have insight to information what your GC is doing, what's your heap allocation, and all that stuff. So that's pretty easy, and okay, it's not that. So okay, what was the okay? There are also the alerts. So I've configured the alerts also with Libretto. This is errors count. Here are we are tracking this particular metric. If this particular metric will be above 10, then the status will be red, and I will be notified by email that something is wrong on my server. Hopefully, okay. So we've got some stats from the heap. Probably the rest will come in a second. So we can have a look at how many bytes are allocated, what is the heap, what is here. I guess it should be the pauses of the GC, but it will probably come in future. Last 5 minutes should be. Okay, we've got some error count, which is a 0. We've got some GC pause, first one. So here we can track also the pauses of the garbage collection and so on. So as you can see, it's pretty easy. 10 lines of code, and you've got a tool which tracks all the metrics from your GLUG process integrated. Okay, and last one, the release process. So if you came to release, then you have to think about how to release that. So this is the Rubino Go code, I guess. So it's the last point where just to create the release notes, and that's my advice. Always create the release notes and put it somewhere. This is how we can do that with Jira, and how to generate automatically from Jira. You can use the Git log, which is where you can put the difference between those, like one tag and another tag, and then you will just have the history of your commits. And create a release plan, just to think when you would like to release your code, what will happen if something goes wrong, if you have to revert some changes, if you have to revert the database, if you have to revert your application, how to do that, how to automate that, just not to make the fault. And also the process itself, probably you should automate it somehow. There's lots of tools for that. You can of course use the Docker images you could. Sometimes Bash is enough. And if you're not using the Kubernetes, Docker, or anything, please use the systemd or supervisor or unit, which are, those tools are just tracks your services and run them if they are be down somehow. And also think about the downtime and how to minimize that. How that you can use the graceful shutdown. You can use the rollbacks. The rollouts, from the Kubernetes, where you can just one by one kill the applications which implements the graceful shutdown, and then start the new one.
This is also possible in Swan.
Yeah, of course /swan. Okay. And the canary deployments. So sometimes if you're big enough, you can think that maybe it's nice to run your server for 5% of the users, and just to track the logs and monitoring if your system is up and running for this particular 5%. This is also something, if you've got a cluster of the servers, it's worth to think to, for example, run something just for a small number of clients. Okay, thank you very much. That's it. Any questions?
May I ask if you have some tools for caching panics when you run your server as a demo? As a demon, you have to catch somehow panics.
Okay, you mean panics from the Go code?
Yes.
Okay, there is a way. Of course, you can. There is a.
You can recover.
You can recover.
But recovering has many downsides.
Yeah, it's always better to let your application crash
Yeah.
and
Yeah.
then restart it with the
Exactly, but this way it's not easy to get the panics because it's
the stackers.
yes it was run as a demo, so don't have the
But it should be in the logs, at least on the standard output.
Yeah, the standard output. Probably not in the file.
So for example,
But
But
Right.
instantly you can cache it.
Yeah. Then you can use the journal CTL.
Yeah.
If you're using this, then you can. I will show you on the production server. Why not? Bum. Bum, and here is the logs.
I want to edit the video at this moment.
No.
Don't use the camera.
And here is you can. It's like in less. You can grab this file, and here is how you can find out what's the standard output of this particular service. So that's the command sudo journal ctl -u in the name of the service, and then you will grab all from the standard output. If you use a Docker, then of course it will be locked because Docker provides that from the outside.
and Kubernetes also stores the log. Even if your pod will crash, then you can check the logs from previous instance of this pod. So you can also
This is another point where you should use the log management.
Yeah, but I don't think so that you will be fast enough to send the logs before they panic. Probably it won't be sent. So the standard output is the only way how to find
Yes.
out the structure.
That's another error.
Yeah. So, okay, so there's no questions. So thank you.
Thank you.